All right, so we are moving to a polynomial times a polynomial and practice. Polynomial, more than one, so it could be a binomial, could be a trinomial, times a polynomial. And again, could be anything greater than one term. So we did a binomial times a binomial, which is very specific. Now we're transferring that skill to polynomials. And practice. So we're going to talk about a few ways to show how to multiply a polynomial times a polynomial. And again, this strategy is really similar to a binomial times a binomial. It just results in a larger amount of multiplying just because there's multiple terms, potentially more than two terms that you are distributing. So we're still working with this idea of distribution. So you are going to distribute the first polynomial to the second polynomial. So we can use the distribution process. We just don't have the term FOIL. FOIL only works for a binomial times a binomial. So we can't write out FOIL and do the acronym. We have to make this chain of numbers. So one way of doing that is to take, I have a binomial here, times, and then I have a trinomial listed here. So technically speaking, polynomial more than one, and a polynomial more than one. But again, in this, because it's a binomial times a trinomial, I cannot use FOIL. I have to use, I have to list out the distributive property as a chain. So I'm still using the distributive property. It's just a little bit longer of a process because I have three terms that I'm distributing to. So I'm going to take 2x and multiply by x squared. 2x times x squared is 2x to the third. Then I go back to 2x and I multiply to positive 8x. And I get plus 16x squared. Then I go back to 2x and I distribute to minus 6 or negative 6 to get negative 12x. And then I'm going to take my second term and multiply to x squared. So negative 5 times x squared is negative 5x squared. Negative 5 to 8x is negative 40x. And negative 5 to negative 6 is positive 30. So it's the same process, it just is a little bit longer of an answer before we can start simplifying. So I look to see for like terms, and I have x to the third, so 2x to the third. I have 16x squared minus 5x squared to get positive 11x squared. I have negative 12 minus 40, so negative 12x minus 40x, which is negative 52x. And then last but not least, I have plus 30. So I have my final answer. So one way is to just distribute and make this long list. Potentially, it gets a little out of control if you have, you know, a trinomial as your first polynomial times a trinomial. So there's another way of organizing our work. And that new way is the table or the grid method. So that looks like this. So if I have 4x squared plus 3x minus 1, so a trinomial times another trinomial. So typically speaking, when we have anything larger than a binomial times a polynomial, we're going to use this grid method. And so the grid method is, because this is a trinomial, I'm going to make a 3, and this is a trinomial, by 3 grid. So I'm just going to, oh, I went too big. Make a 3 by 3 grid. So I have 3 and 3. And then each term is going to go in a grid spot. It doesn't matter which one you put on top, which one you put on the side. Both are going to be the same. Typically, I put just the first one listed on top. So it's positive 3x minus 1. And here I have x squared minus 3x plus 7. Now this would work for a binomial times a binomial also. You could make a 2 by 2. It's just a little bit more work than I think foiling is. And so then what you do is you put the answer to the multiplication in here. So 4x squared times x squared is 4x to the 4th. 4x squared times negative 3x is negative 12x to the 3rd. 4x squared times 7 is 28x squared. Then I move to the next term. 3x times x squared is 3x to the 3rd. 3x times negative 3x is negative 9x squared. And 3x times 7 is 21x. And my last, negative 1 times x squared is negative 1x squared. You can leave that coefficient of 1 off, but do not leave the negative off. Negative 1 times negative 3x is positive 3x. And negative 1 times 7 is negative 7. The nice thing about the grid method is that typically, not all the time, but typically, your like terms line up. Uh-oh, I don't have a different color of highlighter. Your like terms line up diagonally. Again, not all the time, but most of the time. Your like terms will line up vertically. So, double check. 3, 3, 2, 2, 2, 1, 1, nothing. Okay, so my answer is 4x to the 4th, negative 12x to the 3rd, plus 3x to the 3rd is negative 9x to the 3rd. 28x squared minus 9x squared minus 1x squared, well, that's negative 10. And 28 minus 10 is positive 18x squared. 21x, positive 3x, is plus 24x minus 7. Now, this would be the same answer if you took this and you distributed all 3 terms. you just have a long line of numbers, right? You'd have all of these 9 values just in a line, which can get a little overwhelming to look at. So the grid method, I'll show you grid method with a binomials and things like that. It's all going to be the same process, same steps. It's just organized a little bit differently. So let's do a couple more practice problems. If we have 3x squared minus x plus 11 times negative 4x squared plus 2x minus 6. So we have some options here. You can either make a long chain and distribute, write your terms, distribute, write your terms, distribute, write your terms, and then collect them. Or because it's a 3 by 3, you can make a 3 by 3 grid. It does not matter. It is your choice. I'm going to show you just the long way, or the long, as not more work, but the long chain of work. So I have 3x squared times negative 4x squared to get negative 12x to the 4th. 3x squared times 2x to get positive 6x to the 3rd. And 3x squared times negative 6 to get negative 18x squared. Then I come into this negative 1x times negative 4x squared. You could write those terms right here. I like to kind of stack them. So negative 1x squared times negative 4x squared, positive 4x to the 3rd. So I'm going to line it up underneath the term that it belongs with. And negative 1x times negative 2x squared is negative 2x squared. I'm sorry, negative 1x times 2x is negative 2x squared. And negative 1x times negative 6 is plus 6x. Now take your time, because it is really easy to drop an exponent, to drop a negative, to mess this up. So you really have to, in the beginning, take your time. So then I'm going to distribute again. 11 times negative 4x squared is negative 44x squared. So I'll line it up under my x squareds, negative 44x squared. 11 times 2x is positive 22x. And 11 times negative 6 is negative 66. And then because I lined up my like terms, I can just combine them straight down vertically. Negative 12x to the 4th plus 10x to the 3rd. Negative 18x squared minus 2x squared is negative 20x squared, minus 44x squared is negative 64x squared. 6x plus 22x is positive 28x, and then minus 66. So it's going to work if you don't use the grid. However, the grid does allow us to see some a little bit more organization. So let's do one last problem, and let's go with x minus 1 to the 3rd. So if you have a problem like this, again, remember, it must be expanded. We talked about this a little bit in our classwork on x minus 1 squared. You cannot use the shortcut of just distributing the outside exponent in. You have to write it x minus 1, x minus 1, x minus 1. And then, order of operations, you're going to do x minus 1 times x minus 1, get an answer, and then take that answer times x minus 1. So let's use the grid just to show that it works for a binomial times a binomial. I'm going to do a 2 by 2 grid. X minus 1, x minus 1. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. Negative 1 times negative 1 is 1. And then I have x squared minus 2x plus 1. So that is my answer to the first two binomials multiplied. Now, I bring down that third binomial and I multiply. Now remember, this, you can either make a 3 by 2 grid, or commutative property tells us I can flip it around. Doesn't matter. And make a 2 by 3 grid. Or you can make a long list and double distribute. Or here, triple distribute because you have your trinomial first. I'll make a, let's do a 2 by 3 grid just because we haven't done it yet. That might be a little small to put my numbers in, but that's okay. X minus 1 and x squared minus 2x plus 1. Again, this will work if you make a 3 by 2 grid also. Same answer, just organized a little bit differently. X squared times x is x to the third. Negative 2x times x is negative 2x squared. Learn from me, make your boxes a little bit bigger. And x times 1 is 1x. X squared times negative 1 is negative 1x squared. Negative 2x times negative 1 is positive 2x, and negative 1 times 1 is negative 1. And I look for my like terms, which again are diagonal from each other. So x to the third, negative 2x squared minus 1x squared is negative 3x squared. 1x and 2x, positive 3x minus 1. And that's my answer.